In this video, we're going to focus on parabolas. So let's talk about some equations that you need to know. So hopefully you have a sheet of paper with you and a pen to write down some notes. So for the parabola on the left, this corresponds to the equation y squared is equal to 4px. And you would use this if the vertex of the parabola is the origin. For the equation on the right, it's x squared is equal to 4py, with the vertex being at the origin as well. The focus is to the right where the parabola opens towards. So for this parabola, it's somewhere in this region. P is the distance between the vertex and the focus. Now, if you go p units in the other direction, you're going to get something called the directrix. The directrix is p units away from the vertex. For this particular graph, it's going to be x is equal to negative p. Now, when p is positive, the graph is going to open towards the right. When p is negative, it's going to open towards the left. For this graph, the focus would be somewhere in this region. It's going to be p units away from the vertex, and then p units below that, we have the directrix. In this case, we have a horizontal directrix, thus the equation will be y is equal to negative p, as opposed to x is equal to negative p. Now, going from the focus to the curve, that's a distance of 2p. And going in the other direction is a distance of 2p. So the segment that connects these 2 points on the curve and that passes through the focal point, that segment is known as the latus rectum. The latus rectum has a length of 4p. It's basically the focal diameter of the parabola. Now, when p is positive, the parabola is going to open upward, if you have this equation. And when p is negative, it's going to open downward. So that's a simple introduction into parabolas, but let's begin working on some problems. By the way, for those of you who want access to the full version of this video, feel free to take a look at the links in the description section below this video. So let's go ahead and continue. Graph the equation shown below. So this equation is in the form x squared is equal to 4py, with the vertex centered at the origin. There's no h and k in this equation, which we'll talk later about that in the video. Now, the first thing we need to do is calculate p. 4p is the number in front of y. So we're going to set 4p equal to 8. Dividing both sides by 4, p is going to be 8 divided by 4, which is 2. Now, once we have our p value, we can go ahead and graph the equation. So first, let's plot p. The vertex is at the origin, and going 2 units up, we get the focus, which is here. So the focus is at 0, 2. Now, once you have the focus, what you want to do is you want to go 2p units to the right and 2p units to the left. If p is 2, 2p is 4. So we're going to travel 4 units to the right and 4 units to the left to get 2 additional points. And then we can draw a rough sketch of the hyperbola. So keep in mind, this here is 2p and this part is 2p. Now let's write the equation of the directrix. So we're going to go p units below the vertex, and then we're going to draw a horizontal dashed line. So that line is at y is equal to -2. And that's the equation of the directrix. So that's it for this problem. That's how we can graph this particular parabola. Number 2, graph the parabolic equation shown below. Find the coordinates of the focus and write the equation of the directrix, and determine the length of the lattice rectum. So our general formula is going to be y squared is equal to 4px. So let's begin by setting 4p equal to the number in front of x, which is 2. So 4p is equal to 2. Dividing both sides by 4, we get p is 2 over 4, which reduces to 1 over 2. So now that we have the value of p, and we know that the vertex is centered at the origin, let's go ahead and graph it. So for this equation, the graph is going to open towards the right, since p is positive. The vertex is at the origin. Let's put some points here. Since p is small, I'm going to space out each point. Now p is 1/2. So 0.5 units to the right of the vertex will be the focus. Now I'm going to travel up 2p units and down 2p units. If p is 1/2, 2p is going to be 1. So the next point will be here, and the other point will be here. So to graph it, it's going to look something like this. Let's see if I can draw a much smoother graph. We'll go with that. So the coordinates of the focus is the x value is 1/2 and the y value is 0. Now going 1/2 units in the other direction, we're going to get the equation for the directrix. And that's that x equals -p or x equals -1/2. So now we have the equation of the directrix, and we have the coordinates of the focus. The last thing we need to do is determine the length of the lattice rectum, or the lattice rectum. And it's basically the focal diameter connecting these 2 points in the curve. So we know this part is 2p, this part is 2p. Thus, the length of the lattice rectum is always going to be 4p. So p is 1/2. 4 times 1/2 is 2. So the answer to the last part of the problem is 2 units long. Number 3, match each equation to one of the graphs shown below. So let's start with this one. X squared is equal to 4y. When you have y and x squared, that's a graph that's going to open up or down. Now there are no negative signs here, so this one is going to open up. So therefore this corresponds to answer choice A. The next one, y squared is equal to 4y. When you have y squared and x to the first power, this is going to open either to the right or to the left. But since there's no negative sign, it's going to open to the right. So this is B. Now for C, y squared equals -4y, it's opposite to this one. So if this one opens to the right, y squared equals -4y is going to open to the left. The last one, D, x squared equals -4y, is opposite to A. So this one is going to open downward. So make sure you understand how to associate the correct orientation of the parabola with the appropriate equation, because you need to know this if you're going to study for a test. And this is going to be very important whenever you need to graph a parabola, especially the harder versions. So just to review, when x is squared and y is not, it's going to open either up or down. So for this one, when it opens up, we have +4y. When it opens down, there's going to be a negative sign. So this is x squared is equal to -4y. Now, when y is squared and x is not, it's going to open either to the right or to the left. When P is positive, it's going to open to the right. When P is negative, it's going to open to the left. So make sure you understand this. Number 4, write the standard form of the equation for the parabola with the given conditions. So we're given the coordinates of the focus and the equation of the directrix. So let's go ahead and plot the information that we have here. So let's start with the focus. So the focus is at -3, 0. So there it is. And then we have the directrix at x equals +3. What we need to find is the vertex. The vertex of the parabola is going to be the midpoint between the focus and the directrix. The focus is at +3, the directrix is at -3. So when you average those two numbers, you'll see that the vertex is going to be at the origin, 0, 0. So to draw a rough sketch of the graph, we know that it's going to open toward the focus away from the directrix. So this graph is going to open towards the left. Now, in order to write the equation, we need to calculate P. P is the distance between the vertex and the focus, and also between the focus and the directrix. In both cases, we can see that P is 3 units long. Now, is P +3 or -3? The fact that the parabola opens towards the left, towards the focus, means that P is negative. So P is -3 in this case. This part here is going to be 2P, and that part is going to be 2P below the focus. 2P is 6. So if you want to draw an accurate sketch, this point here should be at a y value of 6, and this point here should be at a y value of -6. Now, my sketch is not drawn to scale, but those would be the points that is part of the lactus rectum. So now that we have our P value, we can now write the equation. So what's the general form of the equation for a parabola where the vertex is at the origin but it opens to the left? This is going to be y² is equal to 4px for a horizontal parabola that opens to the left or to the right. Now all we need to do is plug in P. So P is -3. 4 times -3 is -12. So this here is the final answer. This is the standard form of the equation for the parabola with a focus of -3, 0 and a directrix of x equals +3. So the answer is y² is equal to -12x. Number 5. Identify the coordinates of the vertex and focus, write the equation of the directrix, graph the parabola, calculate the length of the latus rectum, and determine the domain and range of the function. So let's begin. So this equation is in the form y² is equal to 4px. Now we know that equation has its vertex at the origin and it opens to the right if P is positive. And we have a directrix here, P units away from the vertex. Now, we do have some numbers associated with x and y. So this particular parabola has been shifted away from the origin. The vertex was 0, 0. Now it has been shifted to some point h, k. When it's been shifted, this equation changes to this. It becomes y minus k² is equal to 4p x minus h, where h and k are the coordinates of the vertex. Now the focus, which was here initially, it initially had the point P, 0. But now once you add the new vertex to it, once you add h, k, the new focus becomes h plus P, k. As for the equation of the directrix, it was x equals negative p, but once you add h to it, it becomes x is equal to h minus p. So let's go ahead and work on this problem. Hopefully you wrote those down. But as long as you understand it, you can get everything that you need. But let's write this equation. Y minus k squared is equal to 4p x minus h. And let's find the vertex. So the vertex is going to be h comma k. So looking at the number associated with x, it's a plus 2. To find h, simply reverse the sign. So this is going to be negative 2. And the number in front of y is negative 3, so reverse it to positive 3. And now we have h and k. So h is negative 2, k is 3. Now the next thing we need to do is find the focus and the vertex. But let's start with a graph. So the vertex is at negative 2, 3, which is here. And now let's calculate p. So 4 is equal to 4p. Dividing both sides by 4, we get p is equal to 1. So now that we know what p is, and p is 1, so we know that this is going to open towards the right. If we travel 1 unit to the right, we'll get the focus. And then we're going to go up 2p and down 2p. So if p is 1, 2p is 2. So that will take us to this point and that point. And now we can graph. Let me use a different color. So this is how our parabola is going to look like. Now let's travel p units to the left. P is 1, so the directrix will be 1 unit away from the vertex. So we can clearly see that the equation of the directrix will be x is equal to negative 3. Anytime the directrix is vertical, it's going to be x is equal to a number. If it's horizontal, it's y is equal to a number. The formula for calculating the directrix is h minus p for this type of shape. But if you don't want to memorize the formula, you could just look at the graph and see what the answer is. H is negative 2, p is positive 1. So negative 2 minus 1, you get negative 3. For those of you who want to see how to use that equation. Now the focus, to find the coordinates of the focus, we could just look at the graph. We can see it has an x value of negative 1 and a y value of 3. Using the formula, it's h plus p comma k for this type of horizontal parabola. H is negative 2, p is 1, k is 3. So negative 2 plus 1 is negative 1. So we get that the focus is negative 1, 3. So right now we have the coordinates of the focus. We have the equation of the directrix. We also have the coordinates of the vertex. And we have the graph of the parabola. The next thing we need to do is find the length of the lattice rectum. So that's going to be the distance between those 2 points. The length of the lattice rectum, as we've considered before, it's always going to be equal to 4p. And since p is 1, this is going to equal 4. The last thing we need to do is determine the domain and range of the function. So for the domain, we're looking at the x values from left to right. The lowest x value is the x coordinate of the vertex, which is negative 2. Since negative 2 is part of the graph, we include it with a bracket. Now this is going to go all the way to the right, all the way to positive infinity. So the domain is from negative 2 to infinity. Now for the range, we're going to focus on the y values, from the bottom to the top. this graph will keep on going forever. It's going to go to the right and it's going to go down. So it's going to go down all the way to negative infinity. And you could follow all of the y values along this curve as it goes up to positive infinity. So for a horizontal parabola that opens to the left or to the right, the range is always going to be all real numbers. If you have a vertical parabola that opens up and down, then the domain will be all real numbers, negative infinity to positive infinity. Number 6, identify the coordinates of the vertex and focus, and basically do everything that we did in the previous problem. So the standard form of the parabola for this problem is going to be x minus h squared is equal to 4p times y minus k. And the vertex is going to be at hk. So let's begin by finding the vertex first. Here we see negative 3, so we're going to have positive 3 for x. For y, we see negative 2, so we're going to change it to positive 2. So that's the coordinates of the vertex for this particular parabola. So h is 3, k is 2. Now let's calculate p. Negative 8 is equal to 4p. Let's divide both sides by 4. And so p is going to be negative 8 over 4, which is 2. Now let's go ahead and sketch a graph for this parabola. So let's begin by plotting the vertex, which is at 3, 2. Now, what direction will the graph open? Will it open to the right? Will it open to the left? Will it open up? Or will it open down? What would you say? The first thing we need to pay attention to is which variables are squared and which ones are not. X is squared, y is not. So whenever you have y equals x squared, this is a parabola that opens up or down. And since p is negative, this is a parabola that's going to open in a downward direction. So p is negative 2. We're going to go down 2 units, and this will give us our focus, which is here. So we can see that the coordinates of the focus is at 3, 0. The formula to calculate the focus for this type of parabola that opens up or down, it's going to be h, comma, k plus p. H in this example is 3, k is 2, and p is negative 2. 2 plus negative 2 is 0. So we get the point 3, 0. So now that we have the coordinates of the focus, let's find the other points that we need in order to graph this parabola. So we're going to travel 2p units to the right and 2p units to the left. P is negative 2, so 2p is going to be negative 4, but we're going to use the absolute value of that. So the absolute value of 2p is 4. So we're going to travel 4 units to the right from the focus, and then 4 units to the left. And now we can sketch our parabola. So now let's go up p units. This will give us the equation of the directrix. So here the y value is 2, here it's going to be 4. Thus the equation of the directrix will be y is equal to positive 4. When dealing with a vertical parabola, the equation that you need to calculate the directrix is this. Y is equal to k minus p. k is 2, p is negative 2. So you get 2 minus negative 2, which is the same as 2 plus 2. And so you get y is equal to 4. Now let's determine the length of the lattice rectum. So the lattice rectum is the focal diameter that connects 2 points on the curve and passes through the focus. So we know this part is 2p, the other part is 2p, so that gives us a total length of 4p. Now p is negative, and the length of that segment, we're just going to assign a positive value to it. So technically we need to say that the length of the lattice rectum is the absolute value of 4p. So that's the absolute value of 4 times negative 2, which will give us 8. So the length of the lattice rectum in this example is 8 units long. Now let's focus on the domain and range. Starting with the domain, for a vertical parabola, it's going to be all real numbers. If you analyze it from left to right, the lowest x value is negative infinity, the highest x value is infinity, and x could be any number in between those two extremes. So for any vertical parabola, the domain is always all real numbers. The range is different though. So for the range, we'll analyze it from the bottom to the top. The lowest y value, this can go down forever, so the lowest y value is negative infinity. A vertical parabola like this one has a maximum if it opens downward. It has a minimum if it opens upward. The maximum is basically the vertex. The y-coordinate of the vertex is 2. So the range is going to be from negative infinity up to the y-coordinate of the vertex, which is 2. So that's how you could determine the domain and range for a parabola. Number 7. Write the equation of the parabola in standard form. Identify the coordinates of the vertex and focus, write the equation of the directrix, and graph the parabola. So we have the equation in non-standard form, so to speak. We need to put it in standard form. How can we do this? Well, we're going to have to use a technique called completing the square. But first, we need to know what type of parabola we're dealing with. Notice which variable is squared and which one is not. X is squared, y is not. So therefore, we need to put this equation in this format. X minus h squared is equal to 4p times y minus k. So how can we turn this equation into something that looks like that? Well, we can see that the x variables are on the left, y is on the right. So that gives us some guidance in terms of what we need to do here. Sometimes this software acts up. What we're going to do is we're going to keep the x variables on the left side so we can mirror what we have there. Everything else we're going to move it to the right side. So on the left side of the equation, we're going to have x squared minus 4x, leave a space, negative 8y. When we move it to the right side, it's going to become positive 8y, and negative 4 will change to positive 4. Now we're going to complete the square. So looking at this number, we're going to take half of it, and then we're going to square it. So I'm going to add 2 squared to the left side. 2 squared has a value of 4. Since I've added 4 to the left side, I need to do the same to the right side, such that the equation remains balanced. Now we can go ahead and complete the square. So it's going to be x minus 2 squared. On the right side, we can add 4 plus 4, which will give us 8. So we have 8y plus 8. Next, we could factor out an 8 from 8y plus 8. So this becomes y plus 1. So now we have the equation of the parabola in standard form. So I'm just going to erase what we have here, and then I'm just going to rewrite our new equation here. So now that we have the standard form of the parabola, we can go ahead and find the rest of the answers we're looking for. So let's start with the coordinates of the vertex. Here we have -2 in front of x. We're going to change this to +2. Here we have +1. We're going to make this a -1. So that's the coordinates of the vertex. H is 2, k is -1. Now let's calculate p. We're going to set 8 equal to 4p. So if 8 is equal to 4p, 8 divided by 4 is 2. So we get that p is equal to 2. Now let's go ahead and sketch a graph. Most of the graph will be on the right side. So let's begin by plotting the vertex. So it's at 2, -1, which is here. And then p is 2. So what we need to do is determine what direction the parabola is going to open. Is it going to open up, down, right, or left? What would you say? Well, looking at this, x is squared, y is not. So when you have a general graph y equals x squared, that's a parabola that opens up if p is positive, which it is. So we know the graph is going to go in this general direction. So now we know where the focus is going to be. P is 2, so going 2 units above the vertex takes us to this point. So that's where the focus is. So we could say that the focus has an x value of 2 and a y value of 1. Now let's confirm that with this equation. The equation for the focus when dealing with a vertical parabola, that's one that opens up or down, is going to be h, comma, k plus p. So we know h is 2, k is -1, plus p is 2. -1 plus 2 is 1. So we've confirmed that this answer is correct. So that's the coordinates of the focus. Now let's find some other points. So to get the other points, we need to travel 2p units to the right, 2p units to the left. So if p is 2, 2p is going to be 4. So going 4 units to the right of the focus takes us to this point, and 4 units to the left takes us to that point. So now we can sketch a rough graph of the hyperbola. It doesn't have to be perfect, but at least this will be a good approximation. So now let's find the equation of the directrix. So let's go p units in the other direction. And so the directrix rather, will be here. So this is at a y value of -1, and here this is at a y value of -3. So we can say that the equation of the directrix is y is equal to -3. Now let's confirm it with the equation for a directrix when dealing with a vertical parabola. It's y is equal to k minus p. K is -1 minus p, which is +2. -1 minus 2 is -3. So you want to be familiar with these equations. It's good to know how to use them. So that's why I want to go over confirming our answer with those equations. I want you to be familiar with those equations for the different types of parabolas that you may encounter. So that's basically it for this problem. We did everything that we needed to do.